Right. So now, first of all, so it is well known that the line constants of the transmission line are uniformly distributed over the entire length of the line. Why? Because it is a long transmission line, right? For long transmission lines, so we have to calculate the line resistance and reactance. So all are uniformly distributed, whereas medium transmission line, so concentrated uniformly, I mean lumped network, but here uniformly distributed over the entire length of the line. However, a reasonable accuracy can be obtained in the line calculation for short and medium lines by considering these constants as lumped, right? So line parameters are lumped parameters in the medium transmission line, but here uniformly distributed parameters. If such a assumption of lumped constants is applied to long transmission lines, so that means long transmission line means length is greater than 150 kilometers or 160 kilometers and voltage is greater than 100 kilovolts. It is found that a series errors are introduced in the calculation. That means, suppose we are applying the lumped parameters for medium transmission line. For long transmission line, the parameters are uniformly distributed, lumped are not allowed. But suppose we have to apply the lumped calculation, even for long transmission line also, we have to obtain a serious errors in the calculation of voltage, regulation and efficiency. That's why. So for long transmission line, we did not go for the lumped calculations. We just go for the uniformly distributed parameter calculations only. So by using uniformly distributed calculations, the degree of accuracy is more and more. So for calculation of uniformly distributed throughout the length of the line, so mainly, therefore, in order to obtain the fair degree of accuracy in the performance calculation of long lines, the line constants are considered as uniformly distributed throughout the length of the line. Throughout the length of the line, we have to consider uniformly distributed, not lumped. If we have to consider lumped network for long transmission lines, that may give errors. Suppose for medium transmission line, that is the best one. Lumped network, lumped calculation, lumped parameter calculation is the best one. But that concept is not applicable to long transmission lines. If it is applicable, some serious errors will be occurred. That's why we go for the rigorous method, rigorous mathematical treatment or rigorous mathematical calculation. That is nothing but uniformly distributed throughout the length of the line. So look at the figure. So the length of the line is more and more, that is more than the 150 kilometers, right? So the figure shows the equivalent circuit of three-phase long transmission lines. So this figure shows the equivalent circuit of a three-phase long transmission lines on phase to neutral basis. So for phase neutral, phase neutral, phase neutral, phase neutral, phase neutral, like that going. So this is sending end, this is receiving end. So n number of lines will be there. That is a series resistance and reactance and shunt, susceptance, G plus JB, admittance. The whole line length is divided into n number of sections. Suppose we have to consider the whole complete length will be divided into n number of sections. That's why. So first section resistance R by N, reactance XL by N. Second section R by N, XL by N. Why? Because total resistance is R, total reactance is XL. Now we have to divide it n numbers. That's why R by N, XL by N. Whereas in T network in the medium transmission line, that may be divided into half, two sections. That's why R by 2, XL by 2, R by 2, XL by 2. But coming to the for long transmission lines, so the length of the line having n number of sections. The total length of long transmission line may divide it into n number of sections. That's why each section having the line constant is 1 by nth of those whole line, 1 by nth of resistance, 1 by nth of reactance. That is why R by n, XL by n for first section, R by n, XL by n for second section. Like that we have to, n number of sections we have to divide the resistance and reactance, and also capacitive reactance also. So from the figure, the following points may be considered. So from the figure, the following points. This is the first point. The line constants are uniformly distributed over the entire length of the line and is actually the actual case. Total line constant, look at the figure, the total line constant are completely uniform distributed. Already we have to assume that na. Suppose it is lumped, it may give errors. That's why you don't go for lumped calculations, lumped parameter calculation for long transmission line. Lumped parameter calculation is only applicable for medium transmission line only. So in long transmission line, we have to assume uniformly distributed parameter calculations only. The resistance and inductive reactance are the series elements, already known parameters. Always resistance and reactance are series branch parameters. The leakage susceptance B, admittance is nothing but Y is equal to G plus JB, right? So the leakage susceptance B and leakage conductance G, B by N, G by N. ఇక్కడ ఎలాగైతే n నెంబర్ ఆఫ్ సెక్షన్స్ రెసిస్టెన్స్ టోటల్ రెసిస్టెన్స్ని n నెంబర్ ఆఫ్ సెక్షన్స్తో డివైడ్ చేసాము, అదేవిధంగా ససెప్టెన్స్ని కండక్టెన్స్ని కూడా మనం డివైడ్ చేస్తాం. B by N, G by N ఫర్ ఫస్ట్ సెక్షన్, సెకండ్ సెక్షన్ B by N, G by N, third section B by N, G by N, right? Here n is nothing but n number of sections. The leakage susceptance is due to the fact that the capacitance exists between the line and neutral. ఎందుకు వస్తుంది ఇక్కడ susceptance conductance? Because of capacitive nature. Because of capacitive is there, capacitive effect is considered. Only short transmission line the capacitance is neglected. Medium transmission line we have to consider, as well as long transmission line also we have to consider the capacitive effect. That's why susceptance is come to the picture. Generally Y is equal to G plus JB, Y is equal to square root of G square plus B square, right? మీకు అంతా తెలుసు, నెట్వర్క్ చదువున్నారు అది, right? The leakage current through the shunt admittance is maximum at the sending end of the line and decreases continuously receiving end of the circuit and is approached at which point is value 0. So look at the figure. Leakage current at the sending end side is maximum. At first section leakage current is very very high, and then so it will be for second section somewhat less, third section somewhat less. So that means the leakage current at the sending end is maximum and decreasing towards the reaching receiving end voltage. At receiving end voltage section the leakage current is 0, right? So this is the long transmission line diagrammatic expression. Now analysis of long transmission line, that is nothing but already at the starting I'm giving a one method. So for medium transmission line, calculation of voltage regulation and efficiencies, 3 methods is available. End condenser method, nominal T method, nominal pi method. Those are lumped calculations, lumped parameter calculations. That is not applicable to long transmission lines. Why? Because some errors will be appearing. Now a new method is applicable, that is the rigorous method. Rigorous mathematical treatment is very very suitable for long transmission lines. That's why analysis of long transmission lines by using rigorous method. Look at the figure. The figure shows the single phase neutral connection. Figure shows the single phase neutral connection of 3-phase line with impedance and shunt admittance of uniformly distributed line. Just we have to assume that only. The line is uniformly distributed. Then only we have to applicable to rigorous method, right? Consider a small element, look at the figure, consider a small element in the line of length dx. This is the dx, small length dx, zdax, ydx, right? Small length dx is situated at a distance x from the receiving end. Receiving end nunchi చూడండి ఈ x అనే small length dx is situated or is placed at a distance x from the receiving end. Receiving end nunchi x అనే distance లో ఒక స్మాల్ డిస్టెన్స్ dx ని మనం అజ్యూమ్ చేసుకుంటున్నాం స్మాల్ ఎలిమెంట్ గా, where z is in the look at the figure, z is equal to series impedance of the line for unit length. So this is the z, series element, series impedance of the line per unit length. Y, so this is the y, shunt admittance of the line per unit length. V, voltage at the end of the element towards receiving end. So this is the V is nothing but voltage at the receiving end. V plus dV, voltage at the end of element towards sending end. V is voltage at receiving end, V plus dV is the voltage at sending end. I plus dI, so I plus dI is nothing current entering into the dx element, I current leaving from the dx element, right? Once again I am introducing the parameters. Z, series impedance of the line per unit length. Y, shunt admittance of the line per unit length. V, voltage at the receiving end. V plus dV, voltage at the sending end. So not sending end voltage is Vs, don't confuse. V plus dV is nothing but from sending end to small element dx, the voltage is V plus dV. I plus di, current entering into the element dx, I current leaving the element dx, right? Now then for small element dx we have to take in the z into dx, that is the series impedance. Y into dx, that is the shunt admittance. Right? So this slide already explained. Z, series impedance, Y, shunt admittance. V, voltage at the end of the element towards the receiving end. V plus dV, voltage at the end of element towards the sending end. I plus di, current entering into the element dx, I current leaving the element dx. Now I am taking for small element Z into dx, that is the series impedance. Y into dx, shunt admittance, right? Now look at the figure once again. So obviously look at the figure, dV is equal to, so change in voltage is nothing but V, generally V is equal to Iz, right? Voltage is equal to current multiplied by impedance. Where dV I Z into dx. So from the figure, dV is equal to I into Z into dx. I Z into dx. Therefore dV by dx is equal to Iz, right? Now the current entering in the element I plus di, whereas current leaving the element I, the difference in the currents flow through the shunt admittance of the element is di is equal to current through the shunt admittance element. That is, what, from the figure, what is di? So y into dx. Di is equal to y into dx. So di by dx is equal to vy. So from the figure first, dV by dx is equal to Iz. From the series branch, we have to obtain one equation, dV by dx is equal to IZ. From shunt branch, we have to obtain another relation, that is di by dx is equal to Vy, right? Now, differentiating the equation 1 with respect to x, that is dV by dx ni differentiate chestunna. So d square V by dx square is equal to z constant di by dx and z. What is di by dx? From the second equation, that is Vy. Therefore, d square V by dx square is equal to z into Vy or yzv, right? So this is look like as a differential equation. D square x by dt square is equal to c. What is the solution of that one? Real and active. For that, v1 is equal to k1 into cos h x root ab plus k2 sin h x root ab, right? That is nothing but k1 cos h x root yz. Here ab means this one, k2 sin h x root yz, right? Now, as usual, అక్కడ k1 k2 మనం ఫైండ్ అవుట్ చేయాలి. k1 k2 ఫైండ్ అవుట్ చేయాలంటే మ్యాక్సిమం వాల్యూ కనుక్కోవాలి. డిఫరెన్షియేట్ చేసుకొని దాని ఈక్వేటింగ్ జీరో చేస్తే k1 k2 వాల్యూస్ వస్తాయి. సో డిఫరెన్షియేటింగ్ అబోవ్ ఈక్వేషన్ విత్ రెస్పెక్ట్ టు x, so this one, but we know that dv by dx is iz. So iz is equal to k into root yz sin x root yz plus k2 root zy cos h x root yz. Therefore, I is equal to, we have to take in the z in this side. Root yz by z is nothing but root y by z. Here also root y by z. That means common factor, root y by z. K1 sin h x root yz plus k2 cos h x root yz. So equation 4 and 5 give the expressions of voltage and current, right? So look at the one again. So this is equation 5. So by using this one, we have to getting the current equation. So before that one, equation 4. So this is the equation 4. From the equation 4, we are getting the voltage equations. So from equation 4 and 5, right? So we have to get the equations of voltage and current in the form of unknown constants values, that is k1 and k2. Therefore, we have to find out the unknown values is nothing but apply the initial conditions. k1 k2 కనుక్కోవాలంటే initial condition apply చేయాలి. At x equal to 0, x equal, there is no distance. మీరు ఒకసారి డయాగ్రామ్ చూస్తారంటే డిస్టెన్స్ ఏమి లేకపోతే విఎస్ ఈజ్ ఈక్వల్ టు విఆర్ కదా, ఎటువంటి లాసెస్ లేవు. సెండింగ్ ఎండ్ వోల్టేజ్ ఈజ్ ఈక్వల్ టు రిసీవింగ్ ఎండ్ వోల్టేజ్. సో అట్ ఎక్స్ ఈక్వల్ టు 0, వి ఈజ్ ఈక్వల్ టు విఆర్, ఐ ఈజ్ ఈక్వల్ టు ఐఆర్. Substitute these condition in the above equation. So we are getting the k1 k2 values. K1 is equal to vr1, k2 is equal to another value root z by ir, right? So now substituting k1 k2 in the voltage equation and current equations, so we are getting the v is equal to vr cos h x root yz plus root z by ir sin x root yz, whereas current is equal to root y by z vr sin x root yz plus ir cos x root yz. So now these are the voltage and currents. Now we have to find out, మనం రెగ్యులేషన్ కనుక్కోవాలంటే సెండింగ్ ఎండ్ వోల్టేజ్, రిసీవింగ్ ఎండ్ వోల్టేజ్ తెలియాలి. రెగ్యులేషన్, వాట్ ఈస్ ద డెఫినేషన్ ఆఫ్ రెగ్యులేషన్? డిఫరెన్స్ బిట్వీన్ ది సెండింగ్ ఎండ్ వోల్టేజ్ మైనస్ రిసీవింగ్ ఎండ్ వోల్టేజ్ బై రిసీవింగ్ ఎండ్ వోల్టేజ్ ఇంటూ 100, right? So that's why I'm first of all find out the sending end voltage, sending end current. So for that, putting x equal to L in the above equations. So x plus లో L లెంత్ మనకు తెలియదు, ఎంత లెంతో తెలియదు మనకు. ఒక స్మాల్ ఎలిమెంట్ తీసుకున్నాం, ఆ ఎలిమెంట్ క్యాలిక్యులేట్ చేసాం. ఇప్పుడు ఎల్ అనే లెంత్ని మనం అప్లై చేస్తాం. సో విఎస్ ఈజ్ ఈక్వల్ టు విఆర్ కాస్ ఎల్ రూట్ వైజెడ్ ప్లస్ రూట్ జెడ్ బై వై ఐఆర్ సైన్ ఎల్ రూట్ వైజెడ్. ఎక్స్ ప్లేస్లో ఎల్ లెంత్. సో 10 kilometers or 20 kilometers or it may be a 150 kilometers or more than 200 kilometers. So depending upon the length, so the sending end voltage and receiving end voltage and sending end current may be calculated easily. So now L root yz is equal to L, ఈ L ని రూట్ లోకి తీసుకొస్తే L స్క్వేర్ అవుతుంది. L స్క్వేర్ ని L ఇంటూ y, L ఇంటూ z. సో లెంత్ పర్ అడ్మిటెన్స్ పర్ కిలోమీటర్ impedance per kilometer, that is y into z, capital Y, capital Z. Any small y, small z. Per kilometer is the y admittance, total shunt admittance of the line per kilometer, total shunt impedance of the line per impedance, that is y by z is equal to y into L, that is y by z. So now therefore expressions are sending end current and sending end voltage is Vs is equal to Vr cos root yz plus Ir root z by y sin root yz. Similarly, sending end current Is is equal to Vr root y by z sin h root yz plus Ir cos root yz. Generally, how can you find the sin h root yz, cos h root yz? By using hyperbolic expressions, right? Sin hx, cos hx. Sin hx means 1 plus x by 2 factorial, x square by 4 factorial, like that. You have to give the expressions. So this is the rigorous method for long transmission lines. Calculate the sending end voltage and receiving end voltage, and also sending end current and voltage regulation and efficiency. So right, these are the expressions for the help of hyperbolic functions. Zy by 2 factorial, z square y square by 4 I mean 3 into 2 into 4 into 3 into 2, that is 24. 2 factorial, 4 factorial, like that it may goes. So look at the problem. A 3-phase transmission line, 200 kilometer long has following constants: resistance per phase per kilometer 0.16 ohms, reactance per phase per kilometer 0.25 ohms, shunt admittance per phase per kilometer 1.5 to 10 power minus 6 Siemens. Siemens admittance, Siemens means mho. So ohm ki reverse anamata. Mho raskovachu leda Siemens raskovachu, right? Now calculate the rigorous method. Calculate by using rigorous method the sending end voltage and sending end current, and the line is delivering a load of 20 megawatt at 0.8 power factor lagging. Receiving end voltage kept constant 110 kilovolts, right? So is not I'm taking the, I'm not giving a solution, but I'm explaining. Please listen. After then independence medium transmission line problems is there. So the solution of this one is I'm not putting in the slide, so I'm explaining. Please listen. So they given total resistance per phase, right? R is equal to 0.16. Look at the problem. Resistance per phase per kilometer, right? 0.16 ohm. But total line length ఎంత ఇచ్చున్నాడు? 200 kilometers. 1 kilometer కి ఎంత అంట? మరి 200 kilometers కి resistance per phase is equal to R is equal to 0.16 into 200. 1 kilometer కి 0.16 అయితే 200 kilometers కి into 200. So resistance per phase is equal to 0.16 into 200, that is 32 ohms, right? Next, total reactance per phase. Similarly, this is also per kilometer 0.25, therefore 200 kilometers into 200. So reactance per phase is equal to 0.25 into 200, that is 50 ohms. Therefore total shunt admittance, they given already. Admittance is equal to 1.5 into 10 power minus 6 Siemens. That is nothing. They don't given conductance. They given only susceptance. That's why G plus JB. They don't given G. Y is equal to G plus JB. G 0. 0 plus J into B means 1.5 into 10 power minus 6. So this is also per kilometer, for 200 kilometers into 200. So total shunt admittance per phase Y is equal to J 1.5 into 10 power minus 6 into 200, that is 0.0003 at an angle 90 degrees, right? Now total Z is equal to R plus JXL. We know the R. So 0.16 into 200, that is 32. We know the XL. 0.25 into 200, that is 50. Therefore Z is equal to R plus JXL, that is 32 plus J 50. So converting that into polar form, that is 59.4 at an angle 58 degrees. Now we have to calculate first. Em calculate cheyali manam voltage regulation calculate cheyalante first we have to calculate sending end voltage, right? So calculate sending end. What is the sending end voltage formula? So this is the sending end voltage formula, right? Vs is equal to Vr cos h root yz plus Ir root z by y sin h root yz, right? So by using that formula we have to calculate the sending end voltage. First we have to calculate, we cannot put all the values. First we have to calculate small root yz. So once again, so look at the figure. So Vs is equal to Vr cos h root yz, right? First we have to calculate root yz value, right? Then calculate root z by y value, right? After then we have to calculate cos h root yz, sin h root yz by using these formulas. So first root zy, that is equal to root z, root 59.4 into at an angle 58 degrees multiplied by what is the y value, 0.003 at an angle 90 degrees. So that may be equal to root zy equal to 0.133 at an angle 74 degrees. So from that root zy is 0.13374 degrees. Therefore zy, squaring the value, zy 0.0178 at an angle 148. Now z square y square, again squaring 0.00032 at an angle 296, right? So for the simplification I am calculating the, generally we have to calculate root zy, after then zy, after then z square y square for simple calculation purpose. Now calculating the root z by y, this value root z by root, so this value root z by y, calculating root z by y, that is root z 59.4 into 58 degrees divided by 0.0003 at 90 degrees, that is equal to 445 at an angle minus 16 degrees. Similarly find out root y by z also. Y by z means square root of 0.0003 at 90 degrees divided by 59.4 at an angle 58 degrees, that is 0.00224 at an angle 16 degrees, right? Now to calculate the cos h root yz by using this formula, cos h root yz 1 plus zy by 2. I already calculated the zy value, so right, 1 plus zy 0.0178 by 2 at an angle 148 degrees plus I am calculating z square y square also, that is 0.00032 by 24 at an angle 296, and by calculating all the values and converting that polar form into rectangular form, that may be equal to 0.992 plus j 0.00469, that is the cos h root yz. Now that value converted to polar form, that is 0.992 at an angle 0.26 degrees. Similarly you have to find out sin h root yz, right? So sin h root yz is equal to root yz by yz or 3 by 2 by 6. Root yz value 0.133 at an angle 74 degrees plus yz by 3 by 2 value 0.0024 at an angle 222 degrees by 6. That value, convert all the values polar form into rectangular, we are getting sin h root yz is equal to 0.0362 plus j 0.1275. that may be converted into polar form 0.1325 at an angle 74.6 degrees, right? So now they given receiving end voltage in the problem, right? Already they given receiving end voltage, that is equal to 110 kV. Receiving end voltage kept constant, that is 110 kV, that is 110 into 10 cube by, so this is a three phase, they given three phase values. So manam matra they given three phase transmission line, but they given resistance, reactance, all the values for phase. అందుకే నేను స్టార్టింగ్లో చెప్పాను, ఫస్ట్ మనం ఫర్ ఫేజ్ వాల్యూస్ క్యాలిక్యులేట్ చేసుకొని ఆ తర్వాత దాన్ని 3 ఫేజ్కి కన్వర్ట్ చేసుకుందామని. సో ఈ వోల్టేజ్ వాల్యూ, రిసీవింగ్ అండ్ వోల్టేజ్ వాల్యూ అనేది 3 ఫేజ్ వాల్యూ. సో 110 into 10 cube by root 3 is the phase values. So VR is equal to 110 into 10 cube by root 3, that is 63508 volts, right? Now receiving end current IR is equal to the given power, right? 20 megawatt. 20 into 10 power 6 by general current is equal to power by voltage, right? So IR is equal to 20 into 10 power 6 by root 3 into 110 into 10 cube into power factor 0.8. P is equal to root 3 VI cos pi. From that I is equal to P by root 3 V cos pi. That is 20 into 10 power 6 by root 3 into 110 into 10 cube into 0.8. That is receiving end current is equal to 131 amperes. Therefore sending end voltage, so we know the formula, sending end voltage is equal to, so Vs is equal to VR 63508 cos h root yz value already find out, that is 0.992 at an angle 0.26 degrees plus IR 131 root z by y value 445 at an angle minus 16 degrees into sin h root yz 0.1325 at an angle 74.6 degrees. So by calculating all the values, converting polar to rectangular, the sending end voltage is equal to 67018 plus J6840. That may be converted into polar form. We are getting 67366 at an angle 5 degrees volts. So that is the phase voltage, right? Now converting, మనం వాడు అడిగింది 3 phase, ఇచ్చింది 3 phase problem, but మనం calculate చేస్తే phase voltage. Vs is nothing but phase voltage, right? Now convert phase voltage into line voltage, that is nothing but multiplied by root 3. So sending end line to line voltage is equal to Vs into root 3. Vs value 67366 into root 3, that value is 116.67 kV. That is the sending end voltage, right? So therefore we know the receiving end voltage, we know the sending end voltage. Now calculate regulation. Vs minus Vr by Vr into 100. We are getting the values, right? And also power, Vr efficiency, Vr IR cos pi r by Vs Is Vr IR cos pi r by Vr IR cos pi r plus IR square R, right? And that way we have to calculate in the regulation, and also sending end voltage, sending end current. They calculating only sending end voltage, sending end current. They don't calculate, they don't asking voltage regulation. That's why don't calculating the voltage. Suppose they asking regulation, you can calculate regulation also, right? So another problem, this is the medium transmission lines. I'm not explaining the before for medium transmission line problems, just this problem for today's class. This problem is the last. That means first in second unit, first part is completed. Voltage regulation, efficiency of a short transmission line, medium transmission line, long transmission will be completed for this class. Next class onwards, second part of second unit, that is calculating the ABCD constants for short transmission lines, medium transmission line, long transmission. So after calculating all the ABCD parameters for all the short, medium, long lines, second unit is completed, right? So go for the problem. This is the medium transmission line problem. So a medium single phase transmission line has 100 kilometers long as the following constants. So a 3 phase 50 heads 100 kilometer transmission line has the following resistance per phase per kilometer, right? 0.25. Inductive reactance per phase 0.8, right? And susceptance per kilometer is 14 into 10 power minus 6 Siemens, and the receiving end voltage is 66,000. So So right, so don't confuse. Before problem they given three phase, but this problem they given single phase. That's why this is the phase voltage, but this is the line voltage. Assuming that total capacitance of the line is localized at the receiving end, determine sending end current, sending end voltage, regulation and power factor, right? And also draw the phasor diagram, right? So whatever it may be, for short transmission line, medium or long line, first of all you have to calculate the sending end current, sending end voltage, receiving end voltage they given. So then difference between sending to receiving and by receiving is nothing but regulation, right? So this is the end by using end capacitor method. So you have to explain this one. We know the end capacitor method phasor diagram. Taken VR as the reference, and so VR is the reference. So VS is nothing but VR plus ISR plus ISXL. So VS is equal to VR plus ISR ISXL, right? This is the phasor diagram. Now go for the problem as usual. Before one only, they given resistance per phase, but 100 kilometer they given. Total line length is 100 kilometer, but they given resistance per 1 kilometer ki ichadu 0.25 ani. So 100 kilometer ki enta avuddi? R is equal to 0.25 into 100, that is 25 ohms. Similarly reactance XL 0.8 per kilometer annadu. So 100 kilometers ki 0.8 into 100, that is 80 ohms. Total susceptance Y is equal to 14 into 10 power minus 6 into 100. This is also applicable for 100 kilometers. గుర్తుపెట్టుకోండి, వాడు 1 కిలోమీటర్కి ఇచ్చాడు, మనం 100 కిలోమీటర్ క్యాలిక్యులేట్ చేస్తాం. ఇందాక కూడా అంతా 1 కిలోమీటర్కి ఇచ్చాడు, 200 కిలోమీటర్ క్యాలిక్యులేట్ చేస్తాం. సో ఫస్ట్ టోటల్ రెసిస్టెన్స్, టోటల్ రియాక్టెన్స్, టోటల్ ససెప్టెన్స్, దెన్ రిసీవింగ్ ఇన్ వోల్టేజ్ దే గివెన్ 66,000 volts, రైట్? సో దిస్ ఇస్ నాట్ ఏ 3 phase, లైన్ ఈజ్ ఈక్వల్ టు ఫేజ్. అందుకే మీకు చెప్పాను ఇంతకుముందు ప్రాబ్లంలో వాడు 3 phase సిస్టమ్ అని ఇచ్చాడు, 3 phase transmission line అని ఇచ్చాడు. బట్ ఈ ప్రాబ్లంలో సింగిల్ phase transmission line. That means we don't divide by using √3, right? Therefore load current IR is equal to, we know the power, the given power P is equal to √3 VI cos phi for 3 phase. For single phase P is equal to VI cos phi. So from that I is equal to P by V cos phi. IR is equal to 15,000 into 10 cube by VR means 66,000 into cos pi 0.8. So from that we are getting the load current is equal to 284 amperes. Cos pi r 0.8 అయితే sin pi r ఏమవుతుంది 0.6. So from that diagram, look at the diagram. So for any condenser method, the VR is equal to VR plus J0, IR is equal to IR cos pi r minus J sin pi r, right? So IR is equal to IR cos pi r minus J sin pi r. IR value 284 into cos 0.8 minus J 0.6, multiplying this one 227 minus J 170. So now మనం IR కనుక్కున్నాం, చూడండి IR కనుక్కున్నాం, బట్ IS సెండింగ్ ఎండ్ కరెంట్ కనుక్కున్నాం. సెండింగ్ ఎండ్ కరెంట్ is the combination of IR plus IC, right? IS is equal to IR plus IC. IR కనుక్కున్నాం, but now find out IC, then combination of these two is nothing but sending end current. So charging current IC is equal to, formula తెలుసుగా, charging current is equal to V by XC. V by XC అంటే 1 by omega C, ఆ 1 by omega C పైకి వస్తుంది. సో J Y VR లేదా V Y omega C, whatever it may be. We know the Y value, we know the VR value, then getting J92. Capacitive current is equal to J92. Therefore sending end current is equal to IS is equal to IR plus IC. IR value 227 minus J 170 plus IC value J92. Therefore sending end current IS is equal to 227 minus J 78. So converting this one into parallel polar form, that is 240. Sending end current is equal to 240 amperes, right? Now sending end current kanuko, now drop voltage drop is nothing but that is ISZ, దానికి receiving end voltage కలిపితే sending end voltage ఇచ్చేస్తుంది. So voltage drop is nothing but ISZ, that is IS R plus JXL. We know the R value, we know the XL value, we know the IS value. 240 into 25 plus J80, we are getting this value. Therefore sending end voltage Vs is equal to VR plus ISZ. VR 66,000 plus voltage drop value 11,915 plus J 16,210. By adding this 77,915 plus J 16,210. So magnitude of sending end voltage is nothing but square root of real part square plus imaginary part square. So we are getting receiving end voltage is equal to 79,583 volts, right? We know the sending end voltage Vs, we know the receiving end voltage Vr, right? Therefore voltage regulation is equal to Vs minus Vr by Vr. 79,583 minus 66,000 by 66,000 into 100. We are getting regulation is 20.58%, right? So and also determine the phase angle means tan inverse of imaginary part by real part, right? Tan inverse of 16,210 by 77,915. So we are getting the minus 18.96. We are taking negative value, so it is a capacitive. Because of capacitive current, so we are getting the negative value, the negative angle, 18.96 values, right? Now by adding this one for theta 2, tan inverse of 16,000, so this is for 7, theta 1 is for sending end current, theta 2 for voltage receiving end sending end voltage. Theta 1 is the angle of sending end current angle, theta 2 is the angle of sending end voltage. Now supply power factor angle is pi s is equal to pi 1 plus pi 2, 30.46. Therefore supply power factor is nothing but cos pi s, 0.86 lagging. So on this way you have to calculate the అది ఎటువంటి ప్రాబ్లం అయినా సరే ఫస్ట్ మనం వాడు రిసీవింగ్ ఎండ్ వోల్టేజ్ వాడే ఇచ్చేసి ఉంటాడు. 3 phase అయితే బై √3 వేస్తాం, సింగిల్ ఫేజ్ అయితే ఏం చేయం. First we have to calculate the sending end current IS, then we have to calculate the sending end voltage Vs. Sending end voltage Vs తెలుసు, receiving end voltage తెలుసు. First calculate the voltage regulation with the help of that formula Vs minus Vr by Vr. After then they find out power factor means angles. Suppose they find out efficiency Vr IR cos pi r by Vr IR cos pi r plus IR square r. Like that you have to calculate the all the problems for medium transmission line, short transmission line, long transmission line, voltage regulation, efficiency. This is one chapter. అంటే ప్రతి ట్రాన్స్మిషన్ లైన్స్ కి వోల్టేజ్ రెగ్యులేషన్ క్యాలిక్యులేట్ చేయడం, ఎఫిషియన్సీ క్యాలిక్యులేట్ చేయడం, సెండింగ్ అండ్ వోల్టేజ్, ఫస్ట్ సెండింగ్ అండ్ వోల్టేజ్, దెన్ సెండింగ్ అండ్ కరెంట్, దెన్ రెగ్యులేషన్, దెన్ ఎఫిషియన్సీ, దెన్ సెండింగ్ అండ్ పవర్ ఫ్యాక్టర్. ఇది అది షార్ట్ కావచ్చు, మీడియం కావచ్చు, లాంగ్ కావచ్చు. షార్ట్ అయితే ఒకే ఒక మెథడ్ ఉంటుంది, లాంగ్ అయితే మీడియం అయితే 3 మెథడ్లు, ఎండ్ కండెన్సర్, నామినాలిటీ, నామినల్ పై. ఇక్కడ నా వోల్టేజ్ రెగ్యులేషను అదేవిధంగా ఎఫిషియన్సీ క్యాలిక్యులేట్ చేసేటప్పుడు నామినాలిటీ, నామినల్ పై, ఎండ్ కండెన్సర్ ఏమి లేదు. ఆ డయాగ్రామ్ ప్రకారం ఐఎస్ ఈజ్ ఈక్వల్ టు ఐఎస్ ప్లస్ ఐసీ ప్లస్ ఐఆర్ ఎండ్ కండెన్సర్లో, అదేవిధంగా అక్కడ ఐఎస్ ప్లస్ జెడ్ బై 2 సంథింగ్ నామినల్ పై. ఆ ఫార్ములా ప్రకారం వెళ్ళిపోవడం అంతే, రైట్? So this is the first part of second unit, that is voltage regulation calculation, efficiency calculation of short, medium and long transmission lines, right? Next class, so we go for the generalized circuit constant of a transmission line. Generalized circuit constant is nothing but ABCD parameters. So we have to calculate the ABCD parameters for short transmission lines, medium transmission lines. For medium transmission again 3 methods: end condenser, nominal pi, nominality, and long transmission lines rigorous method, right? Then problems on calculation of ABCD parameters. So second unit is over, appudu complete avudhu. Maybe next week second unit complete cheyచ్చు. Okay amma, ఏమన్నా డౌట్ ఉంటే అడగండి అమ్మా.